Hello everyone, welcome to part 2 of our series on baseline first-person shooter principles with Photon Fusion. So just remembering here, on the first part of this video series, we organized a base project with client client prediction and server reconciliation of a network character controller movement. Um, we organized the 4 steps for rendering accurate camera for FPS, where you can render the game at much higher frame rate than the actual tick rate of the game. In our example, it was 60 hertz tick for the ticks, and it doesn't matter the rendering frequency of the gamer rig. It will feel accurate and snappy, and still retaining full server authority for both things, both movement and the rotation of the character. And we demonstrated that even with a server authoritative gun recoil part. We also showed how you can set up the scene for lag compensation, so you can add objects that have hitbox root and hitbox children that would be part of the lag compensated buffers. But so this is what we did on part 1, and here on part 2, what we're going to do is we're going to finish this whole setup by organizing character animation. And let's without further ado, let's see on the project here, so I can explain better what I'm talking about. So when talking about lag compensation, you were trying to be as accurate as possible with what the player is seeing in his screen. So watching here, we have 2 interesting things. So if you see from this perspective here, my local character, which is, so the red is always my local prediction, my local view on the clients in these examples using that color tag script. So red is always what I have locally, and green is what the server is doing. So if you guys pay attention, my red guy, my character, the prediction is ahead of the server because I'm running my local prediction. But what I see of other objects, like those moving spheres, for example, I'm seeing them in the past because I'm seeing the interpolated version of that. And that's why we need lag compensation to begin with. But when we're talking about an animated character, the thing is, for a super competitive and highly accurate game, you want to make sure that if you're hitting the arm from what you were seeing, you were aiming because you saw the hand, that's exactly what has to happen on the server. So we need the lag compensation to take into account the character animation. So there are a couple of important things to be done here, because we do have the full lag compensation system that can record all the hitboxes and etc. But for that to actually work with animation, we need to sync the animation data, and that's not as simple as you might think. So let's dive a bit into that and explain how you can do, and that's what is being done here. So I'll just show a few more things here just for the sake of visualizing. So this example here is already fully in sync. So if you guys notice, the server steps of the character, they match exactly what the client prediction did at one point. So we would eventually step exactly on the same position because the animation is really fully synced tick by tick here. And I'll explain how this can be done, and I'm going to show the relation between this and lag compensation. So first, let's watch a few things here. So from the lag compensation, I think I removed it here from this test. Let's add it back because I was testing a couple of more things. So let me add back the hitbox manager object that I have removed at some point. Let me just add it back here because I want to show, because you can technically debug and watch everything that the lag compensation is doing. So let's show just that first. So if you tell it to debug the broad phase, you can actually see how it updates the nodes of the hitbox roots, and that's what's gonna make raycasts and overlaps scale if you add a lot of players, because it does have a proper broad phase going on here. But an interesting thing that you can also watch is the history, so you can technically see the full like compensated buffer of everything. So you see here, I'm seeing the server copy of the hitbox buffer of the animated character. I'm running at 60 hertz, so the buffer is quite dense. Because each delta time is just 60 milliseconds, but you get the point here that we have everything recorded on the server side as well. This also exists on the client, but I'm just watching the one on the server side. Okay, so how can we actually make this go together with animation? So first, let's take a look at our character prefab now, which is a new character prefab, as you guys noticed. It's not a capsule anymore, so we have a proper animated character here. I'm using a sample animation from Mixamo, so this is not going to be the one that we're going to distribute in the sample, because these are not redistributable. But the setup is going to be the same, and it doesn't really matter. I just wanted to have an example that's easy to show. So a couple of things. So what I did here is I added our Fusion hitbox root to the root game object of the character prefab, and then I added all the internal all the hitboxes directly to the animated bones. So let's see this one here in particular, for example. So the leg here, you see that it has a hitbox. So the up leg has a hitbox here, and that's set up here already. So when this bone moves, let me move this guy up so we can see it better. So when this guy moves with animation, his legs and everything is gonna move directly with the bone. So this is a basic setup, a straightforward setup that you do every time. So I simplified a bit here the body. Technically, you could have 4 different parts here on the different spine parts. But you see that they also have the head and everything. You could have shoulders. It's typical in Counter-Strike. I think it uses now 18 different body parts. I'm using here 14 on this sample, but it's similarly set up. So that's it basically for the leg compensation things. You add them to. You add the hitboxes directly to the bones, and they're gonna move together with the animation. And it's a straightforward setup here for this part. But what is important then is that we need to sync the animation. So the animation that we play has to be take perfect on the server and on the clients. Not only take perfect, but actually sub-take perfect for the case of rendering in between 2 snapshots. So we have to make sure we have these hit boxes updated exactly to the rendering stage, especially on the client side. But the cool thing is that you do not have to do anything special for the hitboxes, for the leg compensation system. You just add the hitboxes to the animated parts. I'd like to add a note here that the hitbox root lets you assign, let's say, a conservative AABB radius for the whole root. This is going to be totally optional, because we're going to give you an option to really compute the bounds based on the current animation state of each one of these boxes. But because this can be quite expensive, it's a trade-off that you might want to actually just use the broad phase entry to have a predefined radius, which is what I'm using here, instead of recomputing the bounding boxes for each one of the individual limbs when inserting into the search leg compensation structure. The individual rays are still checked against them if you have to check on a character, so we do have early tests to exit, but it does the narrow phase against the accurate hitboxes. But it's a, let's say, a performance optimization option that you might choose to decide to use or not. But anyway, apart from that, it's basic setup. You have the root, hitbox root, and you add the hitboxes to the bones, and that's it for the character prefab. So how do we actually sync the animation here? So a bit about Unity here. So you really cannot use Mechanim for that, because the key for this to work is that we have to be able to set the exact time that an animation should play. So the real only option here for us to use is Playables. So the Playables API lets you do that, lets you specify an exact time at which the animation should play, and this is what's going to allow us to actually do this tick perfect or even sub-tick perfect animation. So I'll show you from Unity here first, and then I will show the code for this. So to synchronize animation, what we're gonna do here is we're gonna add a script. It's actually added on the child here. It's called so this is gonna be distributed together with the sample, but I'm gonna show you guys here that you are gonna probably build your own, because the kind of blend trees you're gonna use, the amount of animations that you're gonna use is gonna be based on your own gameplay. So it's the solution that it's gonna be distributed with the sample is a starting point for you to work on. So what we have here is we have an implementation of a directional blend tree, which is a very common one to use on FPS movements, which means you have an idle animation clip that plays when the character is standing, and you have specific animation clips when you're going forward, one for going backwards, one for strafing right, one for strafing left, and all 4 diagonals. You could also do with only 4 of these animations, but it's better if you have the 8, all the straight ones and the diagonals as specific clips. And if they have to have matching durations for this to be really, really nice. But this is what I have here. And this is how I set up this blend tree. I'm going to show the source code for it. So you set up the animation you want, the animation clip, and you say what is the, let's say, the direction you are moving towards that should be used when you are, that would match that animation. So for example, when you're in the middle, when you're not moving, which is the position on the blend tree, which is the direction is 0, 0, means not moving, you're gonna play idle. And if you're strafing left, that matches if X is -1 and not moving on the backward direction, and so on. So the idea is to set up like this. So this is right, let me show one of the diagonals. So this is back left. So this is one of the diagonals. So diagonal back left. So this is the direction. It's when you're moving both left and backwards. This is exactly. And this blend tree implementation is going to blend between 3 of the animation clips. It's not going to blend, it's not going to snap into each one of these. It's actually, so if you're standing still, it's going to just play idle, but as soon as you start moving, if it's moving exactly in one of the 8 directions, it's going to blend between 2, idle and the direction, until you get to speed. Then it's blending just the weight goes totally to the direction of animation. But when you're going in between these or in the transition, it actually blends between 3, idle and the 2 that you match the angle in between. It blends between those using a barycentric implementation, a barycentric interpolation. So let me show you the implementation of this that's going to be shared with you guys. So this I wrote this based on a few examples, but it's quite straightforward to do something. And if you want to have jumps, and you're going to have to build your own state machine to do this. And the interesting aspect of this is just really 2 things. I'm talking a lot about the blend tree, but the only thing that matters here is you need to be able to set everything about the animation state from the networked game state. So it should derive the animation timing and blend weights from the game state, not the opposite. So it's common for designers to use animation to set gameplay, and this is not wrong, but technically to have it tick accurate, one idea for this is that You can still use animation to, let's say, give you the intentions you want to do, but you have to actually make the game state authoritative in terms of that. And then the final animation that's played should be derived from the game state and not the opposite. So this is the important principle number one. So the weights are going to be derived directly from the direction the character controller is moving towards now and the speed of the character controller. And the time is the second important thing. The time at which the Playables mixer is going to play this is going to be set from the simulation state, from the fusion time, the fusion control of the gameplay. Not, let's say, the animation does not have its own freedom to do that. You have to set the time for that. And that's going to be super smooth, you guys are going to see. So this is the implementation of the blend tree itself. You guys are going to get this from the sample, and it's but it's not really what matters here. Is just doing the either going directly for the so the count of animation. If it's just idle, it's just idle. If it's two directions you're blending towards, is a two directional interpolation here. Otherwise, it's very centric, as I explained before. And so what matters is this: when we call this from outside, it has to set the exact time of the Playables mixer. So so this is the actual mono behavior. So one important note here. Notice that the animation is not a network behavior from Fusion, or either a simulation behavior also from Fusion. It's just a passive mono behavior that has its set animation time and animation direction from outside, from something that is synchronized on the network. And I'm going to show you that next. So it just sets up the blend tree and the whole Playables graph. And here's the important call. So this is what we're going to call from our character controller code. From there, we're going to set, hey, this is the direction the character controller is moving towards right now at this speed, and this is the exact animation time I want you to position the animation clips as well. So this is going to be used both on server and clients to set the exact time and weights of the animation. So we use the direction to set the weights, which is what this does in the blend tree, and time is set from here. Then we tell Playables to evaluate the graph and modify the bones. Bang, our hitboxes are synchronized. And remember, we already discussed the timing for lag compensation. So if you guys remember, first things we have to do is we need to do all of our movement first. So our character controller and also those moving target objects that we had. So they're all running before the lag compensation stuff happens. Then after this all happens, which means we have to call this thing here before during the movement part, and I'm going to explain something important about a proxy object that you're not predicting movement. So this is going to be called. Then the lag compensation manager is going to grab all the current hitboxes positions and set on the buffers. And after that is run, we're going to run our weapon scripts that actually shoot projectiles, or the projectile scripts that actually check the delta raycasts if we're using projectiles that move ballistically. So this was already explained on the previous video. I'm just reinforcing here because it's still the same. And the point here is that animation in this case is part of the movement. So you have to move the body parts as part of your movement scripts. So let's see how this is called here. So it's a very simple modification. So you see, this is just a way for you to exactly set the animation weights and the animation time, which is going to mean that everything is going to match given the same input to the precision possible given to floats, based on the fact that floats are not deterministic on different platforms. So but that's out of the scope here. It's close enough. And so this is all that you need to make sure the timing and weight can be set exactly to a tick. But then how do you call this? So what we do here is, so I added here this method to our player movement script that lets us update the animation based on a certain time. So what I do here is I grab my velocity from my character controller, as I said. I check the XZ. So this, I'm not doing anything for jump here. Of course, you want to have a little bit more complex state machine. The point is, you have to have a way to grab the state of your character and set the weights. If the weight should be I'm jumping up or I'm falling down or you set those and you do not use the movement blend trees. But I'm demonstrating here with a movement, a directional blend tree. And the point is you derive the games from the game state the data you need, and then you call on that passive behavior tree controller the exact animation you want it to play, which is you set the direction I'm moving towards, my speed with some control based on the animation. I added a control variable here because the animation might be slightly different speed, and you pass the exact time. But I did not explain yet what time is this. So this is a trick here. So this script here, which is fixed update network, which is being called on the server and on the client, but only for, on the server this is called for everybody, and on the client this is called for an object that you have input authority, which means you are moving that, so you're doing prediction. So for this object, what we need is the time is computed based on what is the current predicted state time plus how much extra time on our delta has accumulated, our clock has accumulated already towards the next tick. So this is the interpolation we use to make it smooth for our own character. On the server, this here is going to be 0, so it's just going to snap exactly to a tick. So it's going to update the animation of every single character exactly to a tick when registering on the hitbox lag compensation buffers. So we call this update animation with this. But for objects that you are seeing, for a proxy object, the hitbox, the lag compensation subsystem, does an implicit call to render to make sure objects that we are seeing from other players, they have their animations pre-computed. So this is preemptively called, and when it's technically called, it has already been done. So it doesn't. So this animation update timer here on the hitbox root itself, it already controls to make sure this is not called many times. But it will call this, and the important thing is the time you have to pass. So the time for a proxy object is to set the animation timing for a proxy object is going to be in between the interpolation ticks. So it's the time for the interpolation from tick plus delta times how much you are towards the 2 tick. So this is the sub-tick accuracy for hitboxes on your local view. On the server side, we're going to make sure we can raycast against exactly the same data that's being set here. So you compute time like this for a proxy object, and you call the same update animation. Done. That's all to it. Of course, your own blend trees and animation state machines are going to be more complex, but the point is time and the data to set the exact animation state and timing come from the simulation, not the opposite. Then you're going to have tick accurate or sub-tick accurate animation playing, and your hitbox lag compensation is going to work as expected. So yeah, this is a short video. This is all I had to show for now on this topic, and I hope to be able to share this project with you guys soon enough with an animation set of clips that we can technically share. So let's just see the broad phase again here on the server side, and let's move a bit here to see what happens. So, yep, just showing the updates of the broad phase for the light compensation buffers. That's it. So thanks for watching, and see you guys next time.